go with the integration, plus they're going to have different questions probably than you guys had. So we'll go over the solutions to these ones just because some of you didn't need it, so you didn't take it, but it still would be good practice for tomorrow. Remember, there is a long answer portion that has an A, B, C, D antiderivatives, and there is a bonus with trig having to do some like transforming, which it's optional, but it's also antiderivative, aka an indefinite integral. And then I think I mentioned there's at least one or two in the multiple choice that are also antiderivatives and definite integrals. So we'll talk about these in just 1 second, but first, for you guys to be ready for today, I do have up here in the webcam your review exercises ready for us to go over. And I also have the practice test. Kyle was asking about the circle problems. This is a long practice test, aka once we start covering integration, there are tons of practice problems I could give you. But I have gone ahead and circled the ones that are, I think, most helpful. In that this is a great AP question, and it would still be good for you guys to look at, but not necessarily for tomorrow. Not necessarily for tomorrow. Same thing with number 10, a great AP question, a little bit above and beyond. Number 9, I can't see it specifically, or sorry, number 8, is that one circled or no? Okay, I think it should be circled because it says instantaneous equaling average. That sounds a lot like MVT. But that's one where you would be using your calculator to graph it. Anyway, it's a good wording. I just don't necessarily like the exact same function that they gave you. Number 14, also a great AP. Number 15, a great AP, but not required. Ooh, hey, is number 13 circled? Yeah. Do you see how number 13 is giving you a table and asking you for a Riemann sum approximation? Does that sound a lot like a long answer that I mentioned for tomorrow? Except tomorrow, I didn't say trapezoidal. I said I think it's right or left. But it's a similar idea in that you don't have a function, you're not plugging into a function, doing all that extra work, you're actually able to steal out the y values from the table. It actually shortens your work considerably. But even though it's not a trapezoid, this is a great example problem like tomorrow. And then back here, if you guys notice, ooh, a right Riemann sum from a table? Oh my goodness, I gave you all kinds of practice problems. An absolute value? Oh, I think that's in the multiple choice. This one's a little intense. You have to actually anti-derive and plug in k and plug in -6 f of b minus f of a and set equal to 0. It's great antiderivative practice. There probably isn't find a possible k on the test tomorrow. Hey, number 19, do you see an a and b and a c and a d on antiderivatives? Ooh. Even function, not a huge deal. Another table with Riemann sums. Anyway, that's all preparing you. Every single table is preparing you for that long answer tomorrow. Once again, this practice test is bonus, but man, I think I just pointed out some that would be a really good thing to study. But remember, I also have my answer key for that practice test all worked out for the entire practice test, I think. However, you guys just need to look at those circled ones. And for the tables, I tried to make it clear as to what I was doing for the trapezoids or for the, there's a lot here. Or for, hey, can you guys on number 19 really quickly go put a line through letter B? You are not fully able, even though that's a really good one. I don't think I have any exponential functions with like a 3 to the x or a 6 to the negative x. I don't have anything on that or like that for tomorrow. This one is sine squared, which would be cosecant squared. Ooh, I like that trig part. I like the third part of letter B. But I didn't want you guys to stress about memorizing. There is a formula for b to the x, but I don't think we've actually written down that formula. So I just wanted to let you guys know. And when you look at the answer key, b isn't going to be necessary. Okay, anyway, but first, since antiderivatives seem to be a kind of important thing, and since you guys, some of you just took this, let's go ahead and walk through how to take some antiderivatives, yeah? I'm going to pull up a new screen just so that we have extra space. Let's dual page it real fast, bloop, bloop, and then we'll go from there. So, let's see, number 1, how would you guys rewrite it? How did you rewrite it? Good, 3 on the outside, it is x to the 4 over 3, because it's 1 1/3, right? And so that 3 is just chilling. You can think of it as 3 over 1 if that makes life easier. 4 over 3 plus 3 over 3 becomes x to the 7/3. But when you divide by 7/3, what happens to 7/3? flips to be 3/7, and then don't forget your plus C, because you technically box it and be done on the long answer tomorrow. Yes. If it's a long answer, yeah, that's good enough. If it's multiple choice, maybe like doing like a cubed root with an x to the 7th, and that'd be 9/7 or something like that. But either way, do you know your power rule? Are you okay with those constants just being able to come out in front? And if you're dividing by a fraction, multiplying by the reciprocal. Number two, wrong side. Any rewriting necessary? No. But just be really, 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 really careful. When you do your x to the 5 over 5 or times 1/5, however you do it, what else was in the front? Don't forget your times 5, right? And then your minus 2, and then you have your x cubed over 3 or times 1/3. And then you have your, wait, what is the derivative of any constant is 0. What's the antiderivative? It should have been 1x and then plus c. Now, the nice thing is these are on long answers, which means I can give partial just like I gave partial on your integration quiz, and just like I'm giving partial today. But you have to remember all these pieces. Remember the constants in front. Remember to get those powers right. And remember, you're not taking derivatives, you're taking integrals. That's going to be an x. How can you check any of these answers? Derive it. So what's the derivative of? 7/3 comes down. 3 is left, and then 4/3. Got it. The derivative, the 5 comes down, a 5 is left, x to the 4th. Got it. Etc., etc., etc. You can always derive to make sure you're good. Number 3, is that something you just have to have memorized?
Yes.
Which is why I believe I said for tomorrow, I gave a quick reminder of, I believe there's a trig antiderivative in the multiple choice. You just have to know it. The positive or the negative and the function that it goes with. Who has a derivative of secant squared? Tangent. And it's a positive tangent. All things that can mess you up on the multiple choice. Wait a minute, but this one needed to be rewritten to be x to the negative 2, right? Did you guys rewrite it?
Yeah.
It's x to the negative 2, and so then you would have to go ahead, and I just did it piece by piece because I knew the first piece and I needed to take some time on the second piece. Negative 2 plus 1 is negative 1 divided by a negative 1 with a negative in front. Oh my goodness, so many negatives. To make it look nice and pretty, we would end up with, not that you had to, a negative times a negative is a positive, and a 1 over x and then plus c. The bonus. Ooh, I remember the hint. I don't know if it's multiple choice or the long answer. I don't think it's the bonus, at least not, I told you the bonus has trig in it. But for the bonus here, is there any quotient rule for integration?
No.
So how do we deal with division? We split it up. 3 over x to the 4th minus x over x to the 4th, which would be 3x to the negative 4 minus x to the negative 3 when I reduce. And we had to use our power rule, x to the negative 3 plus 1, negative 4 plus 1, over negative 3, and then minus x to the negative 2 over negative 2 plus c. Anyway, I'll just stop there for now. But wait a minute, what if we ever had an x to the negative 1 that needed to be anti-derived? This was the answer to x to the negative 2, but what if I had an x to the negative 1 that needed to be anti-derived? Power rule doesn't work. Remember you guys were saying, do you have to write n not equal to negative 1? What's the way of anti-deriving a 1 over x? ln. There you go, ln. But that wasn't on the quiz. There weren't any ln's on the quiz. It was good old-fashioned, lots of power rules, and then one trig rule. And remember, a reminder of the quotient needs to be split up. All right, with that, let's go ahead and bloop, bloop, bloop. I just wanted to show you guys that before tomorrow. I thought that could be helpful. Let me go ahead and cover this guy up real fast. There we go, and then let's get rid of this. Okay, I'm ready for whatever questions you guys have for me. If you don't need me, that's totally fine. Like, you can just be like, I'm going to be working on my own and kind of ignoring you. As long as you're being productive and it's calculus, I don't totally mind. Guys, let's not have any stupid decisions tomorrow. What I mean by that is, can you not lose any dumb points like not updating our table of contents in our notes, or having our homework spirals ready to go with the table of contents ready to go as well. And if we've been absent, we've graded with a color pen in the videos that are online, etc. Can you just make sure those silly things we're getting automatic hundreds on? Okay. But otherwise, Kyle, what do you want to see?
28.
On the review or the practice test?
Review.
And it was number 48?
28.
28. Number 28 is, ooh, do you guys see number 29? Did I give you number 29?
Yeah, you did.
Yeah, I did. Why am I saying that? Did I give you a hint on the test about, hey, I'm going to give you properties?
Yes.
And I'm going to give you like some known areas, and you're not going to be able to take antiderivatives, and you're going to have to use them. Sorry, number 28. Number 28, Kyle, is a lot like practice test if you guys want to peek at it. Practice test number 3. 28 is a lot like practice test number 3. To the 1/2 power is a square root. Number 28 has a square root also. Guys, what do the directions tell you that give you a huge hint as to how to solve? Because we don't know how to do u sub. This is a u to the 1/2. How are they expecting me to solve? Geometry. If I were you, I would write on your practice test the same hint I'm going to tell you for number 28. We have to think circles. Oops. We have to think semicircles. Because anytime we have any sort of square root of, and we wrote this in our notes at one point, it might have been just that you missed it. Whenever we have a square root of, and I keep on meaning to put it in our basic graphs, and I guess I keep on forgetting. R squared minus x squared. We're talking about a semicircle with a radius of r. And so who's this guy? It's a semicircle with a radius of 6. 6, 6. Now careful, you have to look at your bounds. Am I going the entire semicircular area?
Yeah.
Yes. You're looking at your practice test. Are we going the entire semicircular area?
No.
No, you're only going half of it. So if you're doing the entire semicircular area, don't you just need to know 1/2 pi r squared? But in the practice test, if you're only going a quarter circle, it's not going to be 1/2 pi r squared. It's going to be 1/4 pi r squared. Good white. Anyway, Kyle, you see it?
Yeah.
And if we rearrange that square root and square both sides, it's x squared plus y squared is r squared. That's the normal form of a circle that we're used to. This is just the function form, and it's only half because it's the positive square root, not the negative, so it doesn't have the lower portion. All right, what else in the review and or the practice test? Are you guys stuck on, or do you want to hear me work through, or are you like, she said there was a test problem, I would love her to do one. Wyatt?
45.
45 on the review, yeah. 45. Did I say at any point yesterday that there might be a question on the test that uses the words find the area?
Yes.
Oh, yeah. So this one, find the area. The directions are very specific. Let me try to get a much cleaner picture because I do not have room to work on this page. And I do not have my snipping tool coming up. They give me a function that's bounding the region, and they give me a y and an x and another x. Now, hold on. Aren't definite integrals areas, guys? When I'm solving a definite integral, aren't I solving for area?
Yes.
Okay, so that's that concept-y part of section 4.3. A definite integral is the area between the horizontal axis or from a function towards the horizontal axis. So when it says find the area, I just need to connect that with, oh, it's a definite integral. But wait, now I know you're not necessarily using your calculator tomorrow on the test. Remember, stick it to the man. You don't have to like actually get all your numbers added together for a Riemann sum. Just write it all added together and box it, etc. But if you were doing this in your calculator, which you should have done yesterday for the average value problem, right? 1 over b minus a times definite integral. Aren't there places to fill in for a definite integral, right? Don't I need to go ahead and do some, okay. We're doing it in terms of x because this guy is an x. And even if it wasn't, I'm like, I'm too lazy. I want to hit the x button in my calculator. This is the function. Got it. What do I need here?
Yeah.
I need x bounds because everything's in terms of x. So what are the x bounds for this one? 1 and 3. So what's that y equals 0 all about? Well, I know 1 over x is like this. So 2 over x is just a little bit stretched, but it's the same picture. If x is equal to 1 and x is equal to 3, check it, guys. X equals 1, x equals 3. That's here. That's here. That's my function here. Isn't y equals 0 technically the other boundary of the shape? They just gave me that the x-axis is the other boundary, but we should already know that. So y equals 0, x equals 1, the curve x equals 3, they're the four sides of my shape. But all I have to do is just solve the definite integral. Wait a minute, hold on, we pull out the 2, that's easy. How do we integrate 1 over x again?
ln.
Aha! And so, how does the fundamental theorem of calculus work? It's the antiderivative of who or what? B. I'm skipping some steps. Minus the antiderivative of A. Now, here's the tricky thing. If you ever see ln's, question. Oh, sorry, that's not a 3, that's a 2, right? What is ln of 1? Where does ln hit the x-axis? What is the 0 or the x-intercept of ln? Ln of 1 is 0. E to what power is 1? E to the 0 power is 1. So that technically goes away. To be honest, 2 ln of 3 is great and all, but that's not what they're going to put on a multiple choice. They would put ln of 9. Whoa, how are those the same thing? Log properties, remember that the number in front can become a power? ln of 9 is probably what they'll have for you. Yeah, good question though. You had an ln and you had some weird wording and they threw in that extra y equals 0, which we're not totally used to. What else do we want to see? Test review, practice test, something that I mentioned might be on the test and you're like, can you just do this one even though I have it? Cut.
17.
17
On
review? On the practice test. Let's see what number 17 is. Okay, 17 is a little bit out there because there's a K. Good news is some of you guys heard me already mention that there shouldn't be a problem tomorrow on the test that says find all possible values of K. The likelihood of there being one on the AP is extremely high. In the multiple choice or the long answer, something about find a K such that this function is continuous or such that this expression is true. Very high that you see at least 1, if not 3, if not 5, but probably not 5. This one, we have a couple options. A lot of you guys see, if you studied your FTC Part 2 really hard, you might see this a to variable and be like, ooh, I take a derivative of it. In some ways, we could maybe think of that and take the derivative of both sides. Kind of like math, you can add to both sides, multiply to both sides, take a derivative of both sides. We could go that route. But technically, there is no derivative written. There's nothing in the problem that says I need to take a derivative, even though I could. You could just go the straightforward route of, I can actually anti-derive this. And I can anti-derive it from -6 to k. This isn't a hard antiderivative. And I know that that final answer needs to be 0. I could plug in k to the 4th over 4 minus 3k squared all over 2. And then I have my f of b, bless you, minus f of a. If you guys notice, though, this starts to get really gross and really messy, right?
Yes.
So we could keep plugging in, and we would end up with 6 to the 4th, because a negative to the 4th is positive, all over 4, minus 6 squared is 36, 36 and 3. I'm just going to put 3 and 6 squared, if you guys don't mind, all over 2. I could throw in a quick, 2 over 2 to get a common denominator of 4. That's still, 2 times 3 is 6. Okay, well that's going to be, I guess we could do some math with this and manipulating it, because now I have 6 to the 4th over 4 and then 6 cubed all over 4. Maybe that wouldn't have to be quite as hard as I would make it. And over here, I could technically do the same thing to get common denominators. That'd be 6 k to the 4th minus 6k squared all over 4. At this point, I could technically multiply both sides by 4. If I multiply everything by 4, 4 times 0 is just 0. All my little fractions are going to go away, because the 4's are all going to, be gone. So I'm going to have k to the 4th minus 6k squared. Hey, it's a trinomial, I think. Not that we like it, but we have 36 times 6 which is going to be 6 and 3 and 2, 16, times another 6 to make 6 to the 4th. That's 6 carry the 3, that's 9, and that's 12. We have 1296 minus 216, the 6 to the 4th minus 6 cubed, which would be 1080. And we have to go looking for factors, which isn't great, but I'm pretty sure we can find them. Do you guys want to see the other way? Are you tired yet?
Yeah.
Okay. I said we could go the straightforward way and just take the antiderivative and plug in k and plug in f of b minus f of a, antiderivative of k minus antiderivative of -6, and simplify. And I do believe we will be able to factor if you can find the factors of 1080 that are only 6 apart. There we go. The other way is we could have actually used that FTC part 2 and said, what if we put in that derivative of both sides? So I mentioned it was an option. I said we didn't have to do it because we didn't. But we could take the derivative of both sides. The derivative of 0 is just 0, right? And what's the derivative of any integral from a to x? Okay, is that an x? We could just plug in. Wait, we could just plug in? Yeah, we could just plug in. The derivative of any integral from a to x is just the the integrand with the variable plugged in. And my u prime, well, u is just k. U prime is just 1. So therefore, wait a minute. So it's k times k squared minus 3. So k is equal to 0 and plus or minus root 3. There are 3 answers. It says find all possible values of k. So checking out how I did it. I wonder if I did it the long way or the short way. Ooh, I did it the long way because I'm snazzy like that.
Well,
Antiderivative of b minus antiderivative of a.
that means one of those factors can be factored again. Once you get the 2 for 1080,
Oof.
you're going to have 0.
Wait a minute.
What's minus 6?
Yeah, I know. I'm double checking my work.
It means 36.
Oh.
30 and 36?
Makes sense. It makes 1080. And 18 and 1 is 10. Ugh. I had to think about why maybe the fundamental theorem of calculus part 2 didn't apply. But I'm trying to see why. I don't see it right away. Huh. I'm going to save this one. I'm going to ask my CalcBC kids if they find an error in it. Doesn't really help you guys.
Good question, Kyle.
Yeah, it is a good question. Why not?
Very much adequate. Wow.
Huh.
You got the whole squad laughing.
I should have just kept going. We were one almost difference of squares away from the answer. Ironically, we should have been able to take the derivative of both sides, I believe, unless the fundamental theorem doesn't apply. But there's no discontinuity. Huh. Anyway, but if you guys follow my logic, that does make sense as far as why it's plus or minus 6. I just didn't think about one FTC part 2. Kiddos, can I just, one more time, I hate creating a long answer that's totally left blank. Can you please look over one of the right, left Riemann sum with the table examples in the practice set if you don't do anything else on it? That last page, either the top or the bottom. It's really simple. It's really straightforward. I would have loved to have done an example. Wait, is the clock wrong again? Anyway, the bell rang. You guys get out of here. Sorry, I thought I had 2 more minutes, but oh well. The clock's wrong. All right, cool kids. I'll see you later. I'll be here up until I am going to the gym to do a frosh-soft game at 4:15. 4:15. So if you need me, just come before that. Sound good?
Sounds perfect.
All right, I'll be in here during lunch. I'll be in here 7th period. I'll be in here after school. And then 0 period, you could totally come with questions,
Yeah.
but you want things mostly worked out before then, yeah? Tess, we're starting early tomorrow. Like normal. Quarter still come on in and pick out all the 0 period kids as Quarter till.
I'll be upset. So.
Like after nutrition.
After nutrition?
Yeah, no, we're kind of like, I wish we weren't